remember we said they're going to be linear functions. So we are going to have to define, which just means write this piecewise function for a given graph. There's many ways to go about this, different orders you can do. I mix it up. So first of all, I do see that something is happening right here on this one, and this value that we're splitting in is 1, 2, 3. So something's happening left of 3, and something's happening 4, 5, 6 between 3 and 6. So that's maybe the first thing to think about. So I do have something happening here if x is less than or equal to 3. So that's this part. And I do have something happening if 3 is less than x, which is less than or equal to 6. So there's something going on in the x regions there. That's how we do that part. Over here, what's going on? Well, it's a linear function. And remember, for these linear functions, there's only two things we need. We need a slope and we need a y-intercept. So if I get the slope first, I'm going to be like, all right, up 1 over 2 now, up 1 over 1, 2, 3 looks good, definitely. Up 2 over 1, 2, 3. So my slope is equal to negative 2/3 for this line, if it were to be a full line there. And then my y-intercept is up 1, 2, 3, 4. So my b value for that one is 4. So remember, I got the y equals right here, y equals, so I just have to fill in with, try to fit this in here, 2/3 x, and then add 4. So this line will be happening if we have values of x less than or equal to 3. And then this line's easy, it's constant, looks a little weird there, but it is a constant function. There's constantly a y value of 1 in that other area. Be careful of a couple things here, just be careful of this. Right here, it's less than because it's an open circle right there. This one is or equal to because we have a closed circle. And then obviously this is or equal to because of that closed circle right there. So that's why we have those set up the way we do. Next one here, pretty similar except for there's something funky going on when x is 0. When x is 0, we have an ordered pair of 1, 2, 3, 0, 3. So really there's just going to be 3 regions on this one. So here's the deal. This line right here has a slope of, let's see, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, down 1. Okay, up 1 over 1, up 1. That's a positive slope of 1. So I'm going to put it in there 1. You don't have to write it, but 1x. And I'm going to say plus 1, 2, 3, 4, 4. That line, if it were to be a line, would be y equals x plus 4. But that's only happening if, well, we got to go all the way over to here now. Negative 1, negative 2, negative 3, negative 4. That's negative 5 for an x value, and this is 0 for a y value. So this is happening if we have negative 5 less than or equal to x, which is less than 0. That's all right here, left to right, between these two vertical lines right in there. Okay, again, or equal to because of the circle. Show that one more time with color. I think that's nice. So closed circle means this right here. Okay, open circle on this because we have that open circle right there. All right, so back to this now. What do? Well, this middle section is a little goofy. X is 0 is what we would put here. So if x is just equivalent to 0, what's happening? Well, we have a y value of 3. It's like, think of an entire constant line, but only for x equals 0. All right, and then we have, oh, well, if x is greater than 0. So we got less than 0, equals 0, and greater than 0 all covered. And we just got to come up with the slope and the y-intercept. So the y-intercept's 1, the slope is down 1 over 2, down 1 over 2. So negative 1 over 2, x, and then we're tacking on the 1 for that. Okay, hope this helps. And once again, the reason for all of this is we have the greater than here, open circle. So that's why we don't put or equal to.